The way this all breaks down. The first thing is, as a quick review, I've told you all before that your grade on work in the assignments category is based on effort. And what I want you to understand is prior to, like a month ago, I didn't really know you. And so one of the things that we were doing is we were just kind of saying, well, like, if we saw you working hard, then you got full credit because we knew you were working hard. If we didn't see you working hard, then we just looked at what you turned in. And if it looked like you got it done, then we gave you full credit. If you didn't get it done, but it kind of looked like you were working hard, like we sort of like thought about it in a bunch of different ways, then we still gave you full credit. And sometimes that backfired because there were some of you that were working hard, but you didn't get a lot done for one reason or another that was legitimate. And some of you found that out because like you would get a 2 or a 1 out of 3 on an assignment, and then you'd come and talk to us. And you'd be like, well, remember I was talking with Ms. Adams, and I was asking her questions about, the lichens the whole time, and then the period came and I didn't have anything to turn in. We would have been like, oh yeah, okay, fine, we'll change the grade. But now, I know you. And so now, for some of you, not many, but some of you, I'm gonna raise the bar a little bit, and the reason is because I know that you're capable of more thoughtful work. And that's what it really boils down to, this effort. A lot of times people are like, well, I'm trying, I did my work, like I turned in, everything's right. But what we're looking for is for you to be really thoughtful about stuff. Like, for example, if I were to reach into this sink right now and pull out a knife and ask you, would you use this to cut a piece of food and then eat the food? Would you do it? Like, just to be clear, this knife isn't sharp enough to cut butter. Like, this is not a dangerous implement. It's not dangerous, but it was just like sitting on my sink. So if you had like a block of cheese and you had some crackers and you were hungry, would you use this knife that I just pulled out of my sink to slice the cheese and eat the crackers? No, right? What if you went into the cafeteria and there was a tray with silverware in it? Like, you've done this before at a restaurant or something, like there's trays. Would you take a knife out of something like this in the cafeteria and use this to cut food up? Here's my question to you. What do you suppose that's on this knife in my sink that's not on this knife? Like, what do you, I don't know. I don't know the answer to that. But what I think is interesting about this is we have these rules about things like, oh, if it lands on the ground, we're not gonna touch it, but if it was on a table, it's fine. If it comes out of a sink, that's not suitable for food preparation, but if it comes out of like a tray, then it is. But here's the thing, everything in this room, everything in this school is covered with bacteria. There's nothing that's sanitized here. Those forks and knives that go through the dishwasher come out sanitized or pretty close to sanitized, and within a minute, they've got bacteria on them. There's airborne bacteria, there's airborne mold, fungus floating around. Like, this stuff, like, flies in the air. People touch things. Like, if somebody reaches into a silverware tray and they have something on their hand, they leave a little bit of what was on their hand on everything else they touch. Within 5 minutes, everything in the cafeteria is contaminated. The trays, the plates, the silverware, everything that is like, people are breathing, there's bacteria everywhere. There's bacteria all over this room. There's bacteria all over everything you touch. Every time you put something in your mouth, you're like, you've got bacteria. And the thing is, like, it's not bad. Like, bacteria aren't dangerous. It's just that there are some bacteria that are harmful to our health. But bacteria in general, it's not like animals are dangerous. Like, yes, a rattlesnake can be dangerous, but you wouldn't be like, is there an animal there? Keep me away. Because, like, what if the animal is like a poodle? You don't have to worry about that. Or, like a chicken. Like, you don't have to worry about most animals, it's just you gotta know what animal it is. With bacteria, we can't see them and identify them easily, so we're cautious. Do things like, well, if I were gonna use this knife, I would take it out of the sink and wash it with soap and water first, because if there's some harmful bacteria on there, that might get it off, but There's never any guarantee. But here's the thing about it. How many of you have ever thought about that before? I, think about it sometimes, but I'm a doofus, yeah.
I thought about it during the dishes.
Yeah, you think about it during doing the dishes, but most of us just don't. Most of us are just well, this is just we're just going through our lives, and we wash our hands, and we think we're protecting ourselves from disease, and we are, but we don't think about the fact that everything is covered with bacteria. There's bacteria, there's viral particles on everything in this room. We have an immune system that fights most of that stuff off. If it's bad, most of it just isn't bad. So the point here is not that we're gonna learn about that stuff in particular, because we're not. The point here is no matter what you're doing, there's something interesting that you can think about with regards to biology. And when I ask for effort on the work that we do in this class, that's what I'm looking for. I know that most of you are not gonna leave this classroom and think biologically or even scientifically in general, and that's okay, you don't have to. I just want you to be able to. What I want to practice in this classroom is the skill of looking at everything from the perspective of a biologist. That's what I want you to learn. So when I say effort, that's the effort I'm talking about. It's not, come on guys, let's get this done. It's not, let's make sure the answer is right before we turn it in. It's, are we thinking about this as if we're a biologist? Let's talk about this and think about it as if we're biologists. And that's a skill. You didn't necessarily know how to do it when you walked into this classroom 3 months ago, and I want you to learn. That's what I want to work on, and I want you to get there. And so to get there, you just have to try. And I will give you points if that's what I see in the classroom on a day-to-day basis. What I am telling a few of you, not many, but a few of you, is that I think, now that I know you really well, I think you can do better. I think some of you are capable of thinking about biology more while you're in this room. And so I'm gonna raise the bar a little bit, and that means that some of you who have been getting a 3 or a 2 for turning something in are now gonna get a 2 or 1, because I know you can do better. And I think you do too. If you ask yourself, to what degree am I really thinking about biology while I'm in here? If the answer is, yeah, I'm thinking about biology a lot, most of the time, you're in pretty good shape. But if you're one of the people that's looking at their phone right now, instead of thinking about biology, right? But see, do you see what I mean? We know what's going on. I see it, I know it now. I know you so well that I can tell when you're playing with your phone instead of listening. And that's the kind of stuff that I'm gonna be holding you accountable for, because I know you can do better. So what I wanna see is that full-on engagement, and for some of you, that's a little bit of a struggle, not because you can't do it, but because you think it's not interesting. You think, well, biology is boring. And my argument to you is, I believe, and I've seen it happen, that anyone can make almost anything interesting. I think we can all make biology interesting, and that's my challenge to you. And if you want full credit on the assignments, that's what you're gonna do, okay? The second piece is that to get those points, I need to see your work, okay? If you've been working hard all period and you have something to show for it, great. If you've been working hard all period, if you come up to me in 20 minutes when I let you start working on stuff, if you come up to me and you spend the entire time talking to me about biology, that's great. At the end of the class, when I say turn in your work, you're gonna be like, I got nothing. Write a note. You can put a comment in on Canvas, or you can write a note on a piece of paper, take a picture, and turn that in. And tell me, just relate to me what happened in class. And if what you say is, hey, you and I, Bernard, were talking. We were talking about bacteria the entire time. Then I'll give you points. I need you to do that because unfortunately my brain doesn't work well enough to just remember that to begin with. I'm not gonna remember. If you and I have a conversation about stuff and then you don't turn anything in, when I go to grade your work, there is a 50-50 chance at best that I'm gonna remember that and give you the credit that I think you deserve. So take that responsibility onto yourself and remind me, this is what I did. Turn it in at the end of the period. I'm gonna give you time, I'll tell you, turn it in, turn it in, turn it in. If you don't, then what you're doing is you're running the risk that I may not accept it when you do turn it in. So be aware of that. For most of you, if you turn in late work, I saw you working. And again, I know you well enough to know which of you are horsing around and which of you are working on a daily basis. But sometimes that could be wrong. Don't leave it up to chance. Just turn in your work and then I'll know, oh, they got their work done. So if I don't happen to have a one-on-one conversation with you, I will be able to assess the work that you turn in and gauge your level of effort, because I know you well enough to know what you should produce if you've been trying. The last thing that I want to remind you about are the skills, and we took a break from that because at the start of the year we were doing a bunch of stuff with plants, and then we did stuff with aquatic macroinvertebrates, and then we did stuff with lichens, and that was all skill-based stuff. Can you identify these things? Like, can you come up with a scientific question? Those are skills. And then we shifted gears and we focused on some kind of informational stuff like symbiosis and predator-prey relationships, and it wasn't so much about skills there. It was more about just kind of a general exposure to ideas. Even food webs, we didn't emphasize the skills so much as just like, what are the levels of a food web? But we're gonna come back to the skills. As we start talking about biochemistry, the biggest arena in which we talk about skills is gonna relate to your ability to use experimental data to determine how things work, which is a huge part of science. In science, we figured all this stuff out. Like, if you think about things like, how many of you have taken a nutrition class? Raise your hand if you've taken a nutrition class. Does anybody remember how many calories there are in 1 gram of carbohydrates? Does anybody remember that? Or fats? Anybody remember? Do you remember learning about it though? In like nutrition? So these are things you probably, maybe you never learned it, but you probably learned it before. I think there's like 9 calories per gram of fats. Does that sound right? I think that's right. Let's look it up. There you go. 9 calories per gram of fat. Oh, you can't see that. Now you can. 9 calories per gram of fat. I just happen to remember that. Here's the thing. How do you figure that out? How'd they learn that? Like, how do you find the amount of calories in anything? Fat, lipid, like protein, like a piece of paper. Like, how do we figure out how many calories are in things? And the answer is that what we have to do is we have to come up with a way of measuring them experimentally. We have to, when we find calories in fat, you know how you do it?
Are we ever going to do anything with that? Because I know you like light up a fire or something like that.
Yeah, and we are going to do that. Yes, we're going to do that. And basically what happens is, yeah, you burn it. And then we can measure how that affects the temperature of something else. You burn something, the easier it is to use that to heat something up, the more calories it has in it. And that's why we use natural gas as like heating in our homes. And some of you probably have a natural gas stove. That's why we use natural gas instead of like sugar, right? There's a reason that we don't use maple syrup to boil water. We could, but we don't. And part of it is because there's so much more energy in natural gas. Like, it's got way more energy per gram than carbohydrates or lipids or proteins or anything like that. So those are things that we're going to practice as skills. Those are things I need to see. I want to see you doing them. I want to watch you like demonstrate mastery in those skills, and you'll get points based on how well you can do them. That's really different from effort. And but it's related, because if you're not happy with how well you can do a skill, you can get better, and you'll get better by working at it. So there is effort there. but I'm not looking directly at the effort to give you the points for that. I'm looking at whether or not you've been able to master that skill. So grades, if you haven't had a chance, don't do it now, but at some point in the not too distant future, if you haven't had a chance to look at your grades, do that. And then just be aware that I'm going to be raising the standards for some of you, because I think some of you can apply yourself more. I'd like to see that level of effort increase, okay? And then, so real quick, does anybody have any questions about that? Okay, so what we're gonna be doing today, and I'm not gonna belabor the introductory part of this because because it's an all day, and I want you guys to just play around. But I've got these cubes, and the deal with these are that they're taped, and like the sides are taped together to make a cube, and then one face of the cube is taped to like a piece of cardboard. Don't undo any of the tape. Don't like peek or anything like that. The idea is you're supposed to be able to see 5 sides of this and not see the 6th side. And effectively, you can't see these right now, I know, but effectively what we're doing is just sort of an exercise in deductive reasoning. So if we look at this cube, which you can see it's got a 1, a 5, there's a 4, a 6, a 3. 1, 5, 4, 1, 5. What number do you think is on the bottom? 2, right? I mean, we don't know for sure, but it makes a lot of sense that it's a 2 on the bottom because we've got 1, 3, 4, 5, and 6. There's 1 missing. And then here's something. The 1 and the 3 and the 5, they're not colored in. It's like there's stuff on the box, but it's not colored. But the 4 and the 6 have been magic markered. What do you think? Is the bottom magic markered or uncolored, and why? Why do you think so?
Because that makes sense.
Why?
Because then it evens it out.
It evens it out, right? We have 3 that are not colored, 2 that are colored, and 1 that we don't know. Is there another pattern there? Like the 1 and the 3 and the 5 are uncolored. The 4 and the 6 are colored.
They're all even numbers.
Yeah, the even numbers are colored, and we think it's an even number on the bottom, so maybe that's another reason to think that it might be colored. And one of the things that's kind of cool about this sort of work is it really mirrors what we see in science, because we can never be sure. Right? In science, we do these kinds of things all the time, but we don't know for sure, like whether we're right. And sometimes we find out later that we weren't. These cubes are a little bit different because there's a bunch of things going on. There's colors, and there's words, and there's numbers, and there's letters, and there's pictures. There's patterns to all of these things. And arguably, you can come up with some different ways of thinking about them. But what I am going to ask you to do is do your best detective work. And the piece of papers that you have, or in your notebook, what you're going to be doing is, that's not it. Sorry. I apparently closed this. Oops. Okay. So what we're looking for is there's an assignment on Canvas, and we give you printouts, so you're going to do this in your notebook. But basically what you'll start with is you take a look at the cube and then just throw out a guess and evaluate your confidence in your prediction. And then you're going to collect some data. And the data that you can collect, you're going to just draw this figure. It's just a rough drawing of it, it doesn't have to be perfect. And then this is the top. We've got the 4 sides here, and this is the unknown 6th side. And so what you'll do is you'll draw your prediction in, and then you'll kind of draw what you see on the 5 sides that you can see. Once you've got that all kind of drawn out and you've made your observations, then you're going to look for patterns. What do you see? Same deal as we saw here. We see patterns, like it appears to be the numbers 1 through 6 with 1 missing. And some of the sides are colored, the even ones. Some of the sides are not colored. the odd ones. Those are the kinds of patterns that you're gonna be looking for with these cubes. And then after you've evaluated as many patterns as you can find, you make another prediction. Like reevaluate your prediction and talk about why you think that it looks the way that you suspected that it did. And then you're gonna evaluate your confidence in that prediction, and then I'm gonna tell you what it looks like and kind of go through the different connections between the colors and the names and the numbers and the letters and the pictures and all that. Okay,